Hi, question number 10. The line L has equation R is equal to 5i minus 3j minus k plus lambda into I minus 2j plus k. The plane P has equation R minus I minus 2j dot 3i plus j plus k is equal to 0. The line L intersects the plane P at the point A. So if this is the plane, okay, we've got a line intersecting the plane, okay, at A. Now we need to find the position vector of A. First of all, what I want you to realize is that let's take a look at the equation of the plane. Okay, we've got R minus all of that, but again, the line L has equation R is equal to 5 plus lambda. Then I've got minus 3 plus minus 2 lambda, so minus 3 minus 2 lambda, and I've got minus 1, okay, plus lambda times 1 is 1, so minus 1 plus lambda. Right, so this is the equation of vector line L. Now this R is seen here, R plus minus 1 minus 2j. So I've got then therefore 5 plus lambda, okay, minus I, that is minus 1. Then we've got minus 3 minus 2 lambda, minus 3 minus 2 lambda, and this one is going to minus 2, so we got minus 2 here. Of course this is going to dot product with all of that here, 3, 1, and then 1, and then lastly we got minus 1 plus lambda, minus 1 plus lambda, and there's no k here, so plus 0. So I've got then here 5 minus 1 is 4, so 4 plus lambda times 3, okay, and I've got plus 1 times everything inside here, minus 2 lambda minus this is going to be equal to minus 2 lambda, okay, and then minus 5, is that alright, minus 5, hang on a second, 3 minus 3 minus 2 lambda minus 2, that's for J, okay, minus 5, then I have minus 1 plus lambda times 1, so plus 1 times minus 1 plus lambda, and all of that should be equal to 0. 3 times 4 is 12, okay, plus 3 lambda minus 2 lambda minus 5 minus 1 plus lambda is equal to 0. From here, minus 12 12 minus 5 minus 1 is minus 6 here, 12 minus 6 is 6, minus 2 lambda plus lambda is minus lambda, 3 lambda minus lambda is minus 3 lambda minus lambda is 2 lambda, is equal to 0, indicating that 2 lambda is equal to minus 6, therefore lambda is going to be equal to minus 6 divided by 2, which is then minus 3. Now because we've got lambda as minus 3, it's very easy for us to find the position vector of A. The position vector is where the line L is joining the plane P, and that's the point, okay? So we've got then 5 plus lambda, so then I've got 5 plus minus 3 vector I, so all of that's going to give me OA, plus I've got minus 3 minus 2 lambda, so minus 3, okay, minus 2 times minus 3, that's J, and then plus K, and that's going to be minus 1 plus minus 3, and this is for K. And now we've got the vector OA as 5 minus 3 is going to be equal to 2, so we've got 2i plus 6 minus 3 is plus 3, so plus 3j, and then I've got minus 4k. Here we are, that's the position vector of the point of intersection. For the second part, we need to calculate the acute angle between L and P. Now, to be able to calculate the angle, acute angle between L and P, the plane and the line, the acute angle between them, let that be theta. This is the plane, this is the line. Because we're using plane and line, it's not between two planes, so we're going to use sine. But first of all, let's look at their direction vectors. Let me call the direction vector of the line L to be m. M is equal to, so I've got 1, 2 and 1. Then the direction vector of the plane, I'm going to call that 3, 1, 1, n. Okay, so the next thing to do is we can just dot product their direction vectors. So that's going to translate into something. Alright, so we've got 1, 2, 1, 3, 1, 1, which is then 3. Hang on a second. So this is supposed to be minus 2 here, minus 2. So that's minus 2. And therefore 3 minus 2, 1. Oh, it's 3 plus minus 2 plus 1. Okay, sorry about that. 3 plus minus 2 plus 1. So that's going to give us 2. Okay, good. Now we are going to find the magnitude of these direction vectors. Okay, so magnitude of m is going to equal to the square root of 1 to the square plus minus 2 to the square plus 1 square. 4 plus 1 plus 1 is 6, square root of 6, and I've got magnitude of n, which is then the square root of 311 to the square, 3 square plus 1 square plus 1 square, that's 9 plus 1 plus this, 11. Therefore, I'm looking at the sine inverse of these. 2 divided by the square root of 6 times the square root of 11. And if we were to do this on a calculator, we'll get the acute angle as, let us see here, okay, inverse sine, alright, of, I've got 2 divided by a root of 6 times a root of 11, and we should be able to get 14.2517 something, as you can see. Alright, so that's 14.2517, etc. Therefore, that comes to 14.3 degrees to 3 significant figures. Here we are for the second part of the question. Okay, the last part of the question, find the equation of the line which lies in P and intersects L at a right angle. Now, you may have your plane like this, and here's the line L. There's another line lying in here, and it makes 90 degrees. Okay, so we need to find the equation of this line. Okay, remember what was the equation of the plane? Okay, we've got equation of the plane and the line. Okay, their direction vectors. The line is 1 minus 2, 1. So I've got then, if I put this I, J, K, 1 minus 2, okay, and then 1. And then we also have equation of the plane. This was the line, this is the plane. 3, 1, 1, that's the direction vector. Okay, so 3, 1, 1. So what we're going to do, we're going to cross product their direction vectors. So what we're doing, we cross product, okay, their direction vectors. And if we do that, let us see what we get. Here's a plus, here's a minus, and a plus. Okay, now if you were to multiply these out, you could block this. Minus 2 times 1 is minus 2, 1 times 1 is 1, minus 2 minus 1 is minus 3. Then I'm going to block this, and I get a matrix here, 1, 1, 3, 1. 1 times 1 is 1, 3 times 1 is 3, so 1 minus 3 is negative 2. Then I'm going to do this one, and here I've got 1 times 1 is 1, minus 2 times 3 is minus 6, 1 minus minus 6 is 7. So in other words, we're saying that their cross product is going to come to minus 3, 2, 7. Good. Now we're almost there to find the equation of this vector line. Okay, this can have an equivalent vector as, if you want, 3 minus 2 minus 7. It's the same thing. That's an equivalent. Alright, therefore the equation of this line L is going to be equal to, remember, we can take the point A here, and we know that A was found to be 2, 3, minus 4. So we're going to put 2, 3, minus 4, plus some parameter, and then you've got your product of the direction vectors. That's going to be equal to 3, minus 2, minus 7. So here we are. Take care.